Good morning, everyone. Thank you for coming to our session. So I'm Daniel Tong. I'm going to talk a little bit about a big problem in the West, which is dust storms. But it's not just our work. It's part of our core project and also the whole community working on dust storms. So why do we care about dust storm? Sounds like for a lot of people, we don't think there's a problem with dust storm in the United States. However, that's not true. If you look back at American history, dust storm was the biggest environmental problem under climate change. One example was the Dust Bowl. In the 1930s, right after the Great Depression, the US experienced a time period of vast dust storms, collectively called the Dust Bowl, was caused by three problems. One is we are an immigrant country. The government encourage people to go west, and you can cultivate the land, convert forest land or grassland into agricultural land, and you don't have to pay tax. At the same time, we invented a very powerful machineries that can plow very deeply into the land, completely destroy the ecosystem, and we planted cotton, wheat, and other non-native species there. And right after that, we had this drought, extended drought. And everything just worked together, right? With poor land management, drought, had strong wind, we have huge dust storms. Those storms are so powerful, right? You can rip off 75% of the topsoil from farms, buried houses, farms, force the millions of people to abandon their community, to migrate to the West or the cities. And took them several decades to come back. And also you can see on one day, it's called Black Friday. What's Black Friday, Black Sunday? I forgot. But one of the days, those dust storms arrived in Washington, D.C. So Congress was in session, and then noon become midnight. And that's when Congress was started and started the Natural Resources Conservation Service. So the question right now is, are we going to see another Dust Bowl in our lifetime? Now, one side of the story is people think definitely that's going to be one, right? Because if you look at history of American climate, we are seeing severe droughts like the dust storm during the Dust Bowl every once or twice every century, and the last one was 90 years ago. And also people think that global warming is going to amplify the impact of natural oscillation because we're going to have higher temperature that's going to shift the precipitation pattern away from the subtropics, which is the southwestern United States. And we're going to have earlier spring, less river run over in the late spring, and all this going to make it perfect for a storm. However, not everybody agrees. There are people think Dust Bowl was partially man-made. We are also under extreme economic stress at that time, and we also learn our lessons. So right now it's a hot debate. Who is right? We do not know. A few years ago, we started with a project trying to use a satellite trained algorithm to detect the trend of dust storm over North America. We did find that from 1990s to the 2020 decade has a huge increase of dust storms. That was 12% increase per year, which was 10 times faster and in opposite direction of the global dust trend. And there were multiple lines of evidence besides us, and that's increased rainwater deposition and calcium, and also dust deposition in slow, and also fine soil concentration increased, according to Jenny Han, and that's the increase from agricultural expansion. However, there's a debate right now. In recent years, the trend may be changed. So we just launched a new collaborative project. We're trying to bring everybody together to come up with a community consensus of the long-term trend. So if you are interested working on this topic, please contact me. So why we are not sure it's going to be a dust bowl or not? Dust actually is impacting us, our health, our safety on a daily basis. Just give you one example. I spent the entire month of May this year to answer media questions because the dust storm on May 1st, 2023 in Illinois, it killed 8 people, injured 37, and also have 72 cars piled up. So this is the first time that is the storm we have ever seen, and it's first time in the eastern United States. However, this is not a single case, right? Just in Utah, south to Salt Lake City, we had a storm in 2021. It also killed 8 people. But that is the one was in California in 1991. And we have a bunch of this in New Mexico. So we have a category right now on the number of people killed by dust storm on highways. What we found is, it's very interesting right now, that is the storm actually occurred from cropland, not a traditional desert, and also dry lakes. We have a lot of lakes that are drying up in the Western United States. So it's going to be a big problem. So we will need a satellite observation of a real-time change on land surface. For example, when a farm is going to tear the land, you have to incorporate that information into dust model. Otherwise, you will not be able to provide early warning. But this is just one example, right? We have a lot of problems with dust storms. This is a review which is published on Review of Geophysics with a team of 28 experts from WHO, WMO, and Pan American Health Organization. We identified an array of health and safety effects of dust storms that including valley fever, which is a fungal infection caused when you inhale the spores of coccidioides living in the soil in the America desert. And now we know it's not just in the desert. We can go further to the state of Washington. They identified the coccidioides in the soil. So we don't know how far this fungus has spread. And we have animal disease. We have aviation safety. I talk about the roadway safety, marine aviation, and a bunch of others, such as renewable energy. So our team recently have been trying to calculate the economic cost of dust impacts in the United States. And the number is really huge. We have, don't call me on this, but the number right now we got is $225 billion in the year of 2017. The majority of these come from the health impact, which is exposure to dust particles. Dust is a major component of aerosols in ambient air. And then the next one is household. Basically, when you have a dust storm, you have to clean up, right? And you have to repaint the buildings and also a bunch of other housekeeping activities as also take labor to do that. And after that is agriculture, because you have to put a nutrient, lots of nutrients on that. And that's just take a lot of topsoil that's most nutritious, and also renewable energy. If you put the dust impact along with all the billion-dollar disasters, and you find that in the year of 2017, dust is the second only to tropic cyclones. The year of 2017 actually was very unique for tropical cyclones. We have, I think it's 17 tropic storms. There's some very famous ones such as Hurricane Harvey, Irma, and Maria. So this is a very exceptional year. So in other years, I believe that dust could even surpass tropical cyclones. So what are we going to do with so many problems? The first thing we are doing right now with support of NASA Health and Air Quality Program, we are trying to enhance the nation's dust forecasting capability, working along with the National Weather Service. We try to put the satellite data into the model, kind of reflect timely change of the surface using albedo. We started with Moody's albedo. Now, because Moody's is going to retire, we switched to VIOS. This work was in collaboration with Barry Baker of NOAA. You can go to airquality.weather.com to see the real-time forecast. It's already become operational. The second thing we are doing right now is part of our HAQAST core project, which we're trying to bring all the federal agencies, because each agency provide one or multiple dust forecasting. Together, trying to build a community consensus forecast. Right, so the idea is we're going to help them with their wildfire and dust emissions, and then they will provide data to GMU, and GMU will ensemble, and then we release the data to NASA. So with the Tiger project, Tiger team project led by Kevin Koma and Brian Duncan, we were working with NASA Goddard data center. I saw several people. Suhan is here, Jennifer Wei is here from the data center. They are helping us to release the data. So the data right now actually is in LASDL format or ASCII format, in grid format, and also in county level. So you can use that. It's not only for dust, it's also for wildfires. So another thing we are doing other than early warning is outreach. We have developed established a network. It's called Dust Alliance for North America, which is a partnership between scientists and practitioners with the purpose to accelerate transition of science to services. We have about 1/3 from academia and about half from states and federal agencies, including NOAA, EPA, etc. Right now, we have a steering committee chaired by Bill Sprague, and also executive committee with our co-I, Scott Van Pelt, has more than 450 members right now. You can join the organization, the Dust Alliance, if you're interested. So my last slide is going to talk about good news. That with the push of the dust community, the UN General Assembly proclaimed July 12th is the International Day for combating sand and dust storms. This is some pictures that we have been celebrating this year's Dust Day. It's really a big milestone for us. So I want to end my talk with a few thoughts. I think we need a lot of data for dust, but unfortunately, there's not a lot of data in the dusty areas. So, and we're also losing some long-term sites because of funding. We will need a better satellite. Right now, the satellite sensors and algorithms are not capable to detect, a lot of smaller dust storms. Jennifer probably can, talk more about that. And also environmental justice issues. This is not well studied, but I believe this is a very big problem. So I will end here. Thank you very much for your attention.
Great. Daniel, can you stay on? Is there any one question people want before we, yes. Okay.
I told him we could take a clarifying question.
Okay, thank you. So we have next speaker is Yi Lee, Arizona Department of Environment Quality.
Good morning, everyone. My name is Yi Lee. First, I want to thank you, thank to HAQAST for support me to attend this meeting. And I got a chance to skip from heat in Phoenix. It's really cool here. So I'm the research scientist at our air quality improvements plan program at Arizona DEQ. We call it AQIP. And welcome to our session. So what's our AQIP doing? So mostly we are working on the state's SIPs, state implement plan. What's a SIP? SIP is control measurements and strategy that state put together to make sure our policy is compliant with the national ambient air quality standard. So what we're doing is in the SIPs is we prepare the emission inventory for the whole state. We do air quality modeling, and we do the data analysis, and take care of all the technical and the policy questions related to the local and the federal air quality regulations. So I feel like by working on SIP and at the AQIP session, I got a chance to use all the knowledge I learned from graduate school to improve the air quality in Arizona and protect the public health. So that's the current state SIP we are working on. We have the dry land across state. So we got several PM10 no intermediate area, and also we have SO2 and lead issues when the sites nearby the big facility or mining area. And we also have ozone problem in Yuma area, which is another interesting story. I will take a little bit more in later. I want to say the satellite provides a very good source to support our daily work. For example, when I'm doing the air quality modeling for area, I download the land cover data from satellite, and this help me to determine the urban and rural ratio for an area. So I can get a more correctly, more accurate the modeling inputs. And also my colleagues, we use the satellite data to do the exceptional events demonstration. And I'm currently working on PM10. I'm working on the Rito PM10 area. That will be great. I will say it will be great to have like a satellite tool available that I can demonstrate, the dust storm. This dust storm event is from the regional area instead of reading the dust from just a no attainment or maintenance area. So here I want the last topic. I want to last slides. I want to share a successful story about our Yuma ozone case. If you haven't been to Yuma, Yuma is a very small town in the border of Arizona, California, and Mexico. If you compare with Phoenix area, big city, million people live there, it have less population, have less traffic, and that has less like pollution emission. But if you compare with the ozone concentration in Yuma area with the Phoenix, you see it's very comparable. It's very close. From just dividing by the ozone concentration, you will see Yuma. You will thought Yuma is a big city, but actually it's not. When I working on this project in 2018, I found a lot of, because in the DQ we only have one ozone surface monitor at the Yuma area. So when I first working on this project, I found a lot of ozone invalid ozone high concentration is related to the winds from the southwest and south. But I need more information to help me to expand this phenomena, to help me crack this puzzle. So I first presented my results at the AGU in 2018, and it catch some attentions. And with the help from Dr. Dian Wu, she is currently a postdoc at Caltech right now. She provided me some modeling data. So based on this, on those results, we can see most highest elevated ozone concentration events was related to the long-range transportation from California and North Mexico. And also the Dr. Zhen Xu and also her PhD advisor, David Henze, they provide the satellite retrieval data to show me the trend of the ozone and ozone precursor in this area. So we from their satellite data we see the long-range transportation is play a very critical role in this area, and we saw the pollutant ozone precursor pollutant emission is increasing in this area. So the conclusion is those data highlight the importance of international calibration to solve the problem for Yuma area. So finally we work close together to get our results published in the Journal of Journal of Environment Pollution. Sorry, and yeah, that's all I want to talk about. And if you also it's very fun to work at DEQ, and if you have students like in the corner of graduation looking for the job, we do have environment engineering available currently. So please let me know. Yeah, thank you.
Thank you. Thank you. Great presentation. So I just want to let folks at the online know that we'll take all the questions which are posted at the end of the session when all the 4 speakers are presented. So next speaker, we have Yohannes Yimam from Formation Environment.
All right, until it opens. Good morning, everyone. My name is Yohannes Yimam. I'm from Formation Environmental. I'm excited to be here. It's my first time, and excited to learn about the new technologies and also, satisfy the other objective of making connections. My talk today is characterization of dust emissions from Playa and desert source around the Salton Sea air basin. Salton Sea it's in South California. Particularly, I'll be discussing about the Salton Sea Air Quality Mitigation Program by IID. It's a program, in response to the transfer of approximately 300,000 acre-feet of water, conserved water from agriculture areas to urban. So there's a quantification settlement agreement that led to a reduction of, backflow from agriculture field to the Salton Lake, Sea Lake, which results in reduction in, lake leading to an exposure of Playa. The goal of the program is it's a comprehensive, science-based adaptive program to proactively detect, locate, assess, and identify different options to mitigate dust emission from recently exposed Playa. The program has 3 components, right? The first is emission estimate. You cannot manage what you don't know, so understanding where emission comes from. And once those highly emissive areas are identified, then the second goal is plan and design dust control measure. And the third is implement those dust control measures. And you don't stop there, right? You monitor and maintain those dust control measures. The focus today will be on the first one, which is, on the emission estimate. We utilized a number of tools and techniques to estimate emissions on the desert areas and on the Playa, which includes using remote sensing applications, using different measurements, right, modeling, and finally, compiling all this to estimate emission. Our goal is where and when dust emission occurs, how much dust is emitted, when that dust emission occurs, where the plume goes, and then, using all this information to prioritize highly emissive areas for dust control measure. In terms of Playa exposure, we use remote sensing data and different, water indices to identify, the shoreline, and between the shoreline, current shoreline, and the shoreline before the settlement. That's our definition of Playa. As of end of the year 2022, we had about 30,500 acres of Playa exposure. In addition to that, we also utilized plate measures and machine learning to further divide that Playa into different classes. We have open Playa, we have some small pool of water, and also Playa vegetation. We have about currently 7,700 acres of vegetation, Playa vegetation, but there are a big open Playa areas that needs really attention, right? So how did we do emission estimate? We followed this methodology. The first is we need to understand and map the surface, right? Surface properties affecting dust emission, which includes the geomorphic, surface types on the Playa, the crust types, presence of loose sand on the surface, soil moisture condition. So we use remote sensing products and a number of ground truthing and machine learning to map these surface properties. Once we map the surface properties for each unique surface combination, we developed a rule set relating friction velocity to PM10 emission. We used an instrument called PICE-ROL, Portable In-Situ Wind Erosion Laboratory. It just provides a friction velocity at different at different steps, and for those friction velocity, it estimates PM10 emission. So with this, for individual unique surface combinations, we have that rule set. The next step is if you have a friction velocity, then you can estimate PM10 emission, right? And for that, we used weather research and forecasting model to simulate wind speed spatially and temporally. For that, we developed the model, selected appropriate model physics options, and utilized multiple station data sets to nudge the model to reality. In addition, right, when we put the PICE-ROL, we usually put the PICE-ROL on a smooth surface. But in reality, there are a lot of other roughening features, so that needs to be considered. So the effect of vegetation reducing and affecting wind erosion, and also through friction velocity is considered through drag partitioning. And finally, we would have an emission, PM10 emission in mass per unit area at early time step at 30 by 30 meters spatial resolution. Then we work with NCAR to feed that emission estimate to the WRF-K model and use a dispersion and transport component of the WRF-K model to be able to simulate where the plume goes. So in terms of results, this is, for example, one result for the 2020-2021 dust season covering the Eastern Desert and the whole Playa. We are interested in the desert because any measurement of emission, PM10 emission in the region is a function of both the Playa and the desert. So we would like to separate the effect of the Playa so that we can do dust control measure. Generally, if we aggregate it temporally, the emission estimate on the Playa ranges from 0 to about 40 tons per day, depending for highly emissive dates. Whereas on the desert, it can go up to thousands of tons per day. The reason is the desert, it's a big area and usually it's dry, whereas on the Playa it's currently small area, and because it's close to the sea, it's wet, so no emission. Less emission. So when we look between the desert and the Playa is a very small component of the overall air quality currently. So, like I said, we work with NCAR to have this, plume dispersion and transport component that gave us an opportunity to validate our methodology. So, if we look at the comparison of, the WRF-K simulated and also Thorn measured PM10 at a given station for multiple external dates, you can see that really the model really captures the simulation well. And if you look at on the right, the QQ plot, the measured and the model compares really well. That's within the factor of 2 that's acceptable by EPA. And we are hoping to use emerging remote sensing products to be able to validate this more spatially. We are interested in working with EPA. We have been working with EPA to use this as a test method. So we followed their peer review handbook, and we work with different experts in the field, so that they can review our methodology, and we get good feedback from them and additional comments to improve the methodology. And we also published a few papers, and there are some papers currently on the pipeline. So at the end, our interest is to identify high priority areas on the Playa, highly emissive areas on the Playa. If we look at this, this is a 5-year average annual emissions on the Playa, and you can clearly see where, that Playa emission is high. So we could, kind of attack those areas and implement those control measures. If we look at kind of a prioritization tool similar to this, if we look at it, what this shows is 5% of the Playa grid is responsible for, 30% of the total PM10 emission. Likewise, 30% of the Playa area is responsible for 88% of the total emission. So by attacking those few areas, you could significantly reduce emission on the Playa. So at the end, right, you prioritize areas based on the emission estimate, then sort of the proactive disk control plan, that component to recommend and provide different options for disk control implementation on priority areas. Currently, there are multiple projects on those highly emissive areas that are either implemented or on the pipeline. So if you look at this, for example, this is a kind of emission estimate on a particular day on the desert source, on the Playa, assuming that the Playa is uncontrolled, and on the Playa where after implementing currently planned dust control measures, so you can clearly see right where the dust is coming from. Thank you very much. Excited to be here and happy to answer any question you may have.
Thank you. Thank you very much. Okay, so our next presentation is by Thorn Merrill from Ramboll.
There we go. Okay, welcome to my talk titled How Dry Must Great Salt Lake Be to Emit Dust. I'm Thorn Merrill. I'm here with Ramboll, and this is some of my research from my master's thesis I completed this spring at the University of Utah with Dr. Kevin Perry. So this work is motivated by dust air pollution we experience in Salt Lake City and along the Wasatch Front. Mineral dust blows in from dry Playa surfaces to the west and south of the city and can cause exceedances in particulate matter regulations under the National Ambient Air Quality Standards. The closest Playa is the Great Salt Lake Playa. And in order to understand, model, and potentially mitigate this issue, it's important to understand the factors that promote or inhibit dust emission. So why are we talking about dust emission from the Great Salt Lake Playa? Well, over the past 35 years, the Great Salt Lake has shrunk by over 50%, and this has exposed over 800 square miles of dry lake bed. Here in this picture on the left, you can see the previous lake level or lake edge in white, and the 2015 lake level shown in the image. And last summer saw a record low level for the lake, so even lower than this. This is driven mainly by human water diversions up to 40% in recent years and is exacerbated by an ongoing mega drought in the Western US. And on the right, you can see the lake elevation over the past 150 years. The red line shows the measured lake elevation. The blue line is the modeled lake elevation in the absence of human water diversions. So you can see we would expect some large fluctuations in lake level due to the terminal basin lake, but we wouldn't expect this general decrease in lake level over that period. So there's many factors that dictate dust emission potential, including mineralogy, particle size distribution, vegetation, surface roughness, surface crust, and soil moisture. For the purpose of this talk, we're going to focus on soil moisture, but this is also going to bring up some components of surface crust as well. To do this, we used a portable in-situ wind erosion laboratory, and this is known as the Pi Swirl. It's a portable unit that can produce similar results to a standard 10-meter wind tunnel, but we're able to tow it around the Playa on a fat-tired bicycle. It produces a shear stress at the surface, and then we measure the concentration of PM10 and PM2.5 coming off. So using the Pi Swirl, we looked at two different metrics for assessing dust emission. We looked at a threshold friction velocity, so that's when particle movement begins from the surface. And we also looked at a PM10 flux, so that's the amount of dust coming off the surface. High winds in the vicinity of the Great Salt Lake are generally the result of prefrontal southerly flow, postfrontal northwesterly flow, easterly downslope windstorms, and thunderstorm outflow. Here's a cool dust storm captured by Kevin Perry from a thunderstorm outflow. And generally the winds associated with dust storms are 10 to 30 meters per second at 10 meters. So in order to investigate soil moisture, we first needed to determine some of the highly emissive areas around the Great Salt Lake. Kevin Perry spent the years of 2016 through 2018 surveying the lake bed and produced some of this data on the left. So these are potential dust hotspots. These are areas with erodible shallow crust, visible fines, and no vegetation. And then we went out in the summer of 2021 with the Pi Swirl with the goal of hitting a lot of these areas with high concentrations of dust hotspots to sort of get rough coverage of the lake. And one of the things we determined from that study was that Farmington Bay between Antelope Island and the Wasatch Front is a highly emissive area. It's close to many people. It's easy to access. And it seemed like a suitable location for a more focused study on soil moisture. So we implemented two different soil moisture sampling schemes. We call them the natural moisture or NM and artificial moisture sampling schemes or AM. They have similar goals to try to control for surface crust and just look at soil moisture. But for natural moisture, we return to the same dust hotspots over the course of the spring and summer dryout of last summer, with the goal of assessing the conditions each time we returned. And due to many rain and rewetting events during this period, we struggled to adequately control for surface crust. So we developed the artificial moisture sampling scheme, where we tried to investigate the same progression of soil moisture, but over the course of a single day. And that was done by changing the soil moisture using a pressurized sprayer, which you can see here on the right. So now I'm going to present some of the results from that study. First, we're looking at the artificial moisture sampling results. And so these are threshold friction velocities at varying soil moistures. Soil moisture decreases from left to right across the bottom there. And you can see as soil moisture decreases, the threshold friction velocity decreases. So particles are more readily lofted from a drier surface, which is sort of what we expect, although the spread in the data makes it sort of hard to predict from this study and figure out the exact functional form of that relationship. And here we're looking at dust emission flux, again, against soil moisture. And this is for about 25 to 33 meters per second wind speed at 10 meters. So remember, that's about the upper end of winds associated with dust storms in the area. And so what we see is as soil moisture decreases, the amount of dust we're getting off the surface increases, and it increases significantly at low soil moistures. Here's two more sites here from that artificial moisture sampling. And conversely, as we increase soil moisture, there's a point at which we're no longer seeing significant dust emission above a certain soil moisture percentage. And for the artificial moisture sampling scheme for that same wind speed bracket, that's about 4%, above which we're not really seeing significant dust emission. Now you could pick out the similar dust suppression value for any wind speed tested. We just settled on that one. If we switch over and look at the natural moisture sampling scheme, we're seeing a bit of a different story here. There's basically no relationship between soil moisture content and threshold friction velocity, and that's mostly due to that inability to control for surface crust, and starts to show how important that is for dust emission potential. With dust emission flux, we see 4 out of the 11 sites we tested looked somewhat like the one on the left here, where there's really no relationship and just low dust emission flux across the board. And then there were some that showed at least some relationship between soil moisture and dust emission, and probably the most robust one was this NM8 site here, which is a similar functional form to those artificial moisture sampling scheme ones. And so this begs the question of why these two were so different when they had the goal of testing the same thing, and they were tested in a similar area. And a lot of that was due to the inability to control for surface crust during the natural moisture sampling scheme. So during the period we were out there, it was about 3 months, and there was 26 days of rain. And also in June, this large seiche blew over the entire study area and inundated the area with 1 to 2 inches of water. That's an image of it on the right there from Natural Wind Erosion Network site that we installed on the Playa last summer. And this totally changed the crust characteristics of the whole area and really changed our outcome. But comparing the natural moisture and artificial moisture sampling schemes really helps elucidate a relationship between surface crust, soil moisture, and dust emission for these dry Playa surfaces. And in these areas with smooth, sufficient visible fines and no vegetation, they're really the two main buffers to wind erosion in the area. And it's this region in the middle where we can have dust emission, but it begs the question of where are the thresholds for each. As we presented here, for soil moisture, that's about 4%, above which we're not really seeing dust emission from the Playa. But a further question would be, where is that for surface crust? Is it just an intact surface crust, given surface crust on the Great Salt Lake range from a couple millimeters to maybe 10 centimeters thick? So just an extremely variable property, and I think could be the topic of some future research as well. And That's my talk.
Okay, so I will request all our speakers to come here and take a seat, and then we will take questions. Give this to the panel. Okay, these four were really wonderful talks, and I think we had a lot of important information about dust and a lot of activities which is going around making measurements and doing forecasting and emission estimates. So to get the discussion started, are there any, I mean, I have my own questions, but I want to see if there are any questions from the audience here before we go to the online. Okay, Ashutosh. Can we use the microphone?
Yeah.
Sorry.
Thank you, Daniel. A question for you, if I may. You had a really fantastic presentation on the dust forecast. You mentioned North America. Is there any desire, interest, focus, whatever you want to call it, to expand it to the rest of the world?
The next work of what?
The dust forecasting for, say, West Africa or.
Oh yeah. So we have our collaborator is National Weather Service. Right now we are focused on the US, but however, we have parallel efforts going on with the World Meteorological Organization, which I chair their dust research program right now. We do have 4 centers. One of the centers actually cover Africa. And we also have collaborative projects trying to bring all the global models together, trying to come with ensemble forecasting, which is something that I like to discuss it maybe in the future meetings. Yeah, come back.
Okay, thanks, Daniel. So there's a question over here. Can we get a microphone?
Again, my name is Jesse Marquez, Coalition for Safe Environment. We network with other environmental justice organizations throughout the United States that also work on air quality issues. Did you work with any of the environmental justice organizations that work in that Salton Sea area? There's one that has like a network of 50 PM monitors, and actually we're part of that, but they do monitor PM in that area. And if they're not part of your group, then they would be another new, environmental justice organization network that could participate with you.
Yeah, we do start work with those groups, and also right now we have environment in our agency. We recently launched like a community engagement policy and the regulation, like as there's more presentations and more of public hearing on that. We are looking for those new trends.
So because one group established a network, and it's called the AIRE Collaborative, AIRE. And like I said, we're in Los Angeles, but we're part of that 50 network, but they have about 20 to 30 monitors throughout that Coachella and Burial Valley area. And the Salton Sea is one of their concerns. So I could recommend or further give the information for them to network with them.
Oh, yeah, thank you.
That's got his hand up too. Daniel, I was blown away by the economic analysis you did with dust placing so high. And I was thinking, did you include the cost for a PM from smoke, or was that just direct wildfire impact?
Yeah, that's a very good question. So the direct cost of firefighting and others is about $40 billion in 2017. So I add about I think we add $1,110 billion from Neo Fund study. So it's like 5-year average. So we come up with $150 billion for wildfires. That's actually adding the exposure impact. Yeah, that's a good question.
Okay, Scott.
This question is for Tom. It's a lot of Playa surfaces got a lot of capillary rise because the fine materials in them. What depth and how did you sample the soil moisture that you used as a regressor?
Yeah, that's a good question. So we were doing weight percent, so on Western, we were using a 2 centimeter depth sample, and that's definitely certainly a component of uncertainty when you're thinking about, whether the soil moisture is coming from rain or simulated rain with the pressurized sprayer, or whether it's coming from the ground, and sort of something we've thought about but haven't found a exact way to work around that.
Just to add on that, for the Salton Sea, we use soil moisture, and we use remote sensing applications to, to kind of estimate soil moisture. Usually, like, we don't have percent weightness, right? Like, we have a kind of a threshold where we can say it's dry and wet, similar to like the threshold you get, which is like the 4%. For our kids, we developed that, but we train our remote sensing based on field measurement. Just like Daniel, we kind of take, right, the top 2 centimeter, and just if there is any crust, right, you have that top, right, hard crust, but below that hard crust, there's this fluffy, very low bulk density kind of material, and then below that, it can be really wet, but still like that surface can be emissive. So we try to use remote sensing application for that as well.
So I think I want to go to online. There are more questions.
This question's for Daniel. You had mentioned that we need better satellites to take measurements for dust storms. What kind of data products or measurements would you need out of a satellite like that?
Yeah, so if I have my wish list, so I would like some satellite to look through the cloud, which is very challenging. However, most of the most dangerous dust storms actually occurred beneath the cloud, right? So right now we don't have this capability to look through the cloud. That some people using IR infrared data trying to derive that. That's what NOAA actually, NOAA satellite branch, they used to have human operators trying to do that. But now, because of budget cut, they are not doing that anymore. And we don't have any automated algorithm to do that. So this is something I like to say. And also, we want to have a more higher temporal resolution of dust observation. Right now, the port orbiting satellites is great. However, they only give us once or twice a day. And dust storms occurred most time a few hours before sunset in North America. And those satellites just does not pass at that time. So we're missing a lot of dust storms. And also, if possible, I like to have something like a Starlink, right? So if Starlink from Elon Musk, they have a lot of satellites and they fly really low. Right? So that kind of instrument is what we like to have a more complete view of dust activity on Earth.
Okay, thanks, Daniel.
Okay, yeah, we have a question online from Scott Epstein. He says, thank you for your talk, Daniel. We forecast wind-driven PM10 for our air quality forecast and advisories at the South Coast Air Quality Management District. Can you recommend the best satellite products for observing dust in real time? We often check the Deborah dust product and the dust RGB from goes west, but often do not see a signal over the desert, even when our PM10 levels are off the charts.
Yeah, this is the same problem. It's a very good question. The same problem we were talking about. Right now, we just don't have ideal dust observation instrument or algorithm. Right now, I don't have anything to recommend, but I think this dust RGB is a good starting point. And sometimes I trust the true color images from polar orbiting satellites, and also looking forward to see what Tempo can provide.
So I just want to add to respond to that question. NOAA from the GOES-R satellite, they have a product called aerosol typing where they separate dust and smoke. So it's a dust mask. It's not perfect, but it's basically sometimes picks a lot of dust and it can be used in that sense. Okay, Jennifer. Sure.
So my name is Jennifer Wei. So I think the question is very good that, what would be the wish list for NASA to consider for, observing from the satellite observation capability for dust. So I think I want to put a plug here. NASA does have such a working group. It's called Satellite NEAS Working Group, SNWG. And that's actually NASA sort of collaborating with all the agencies and including the international collaborators. So whatever your wish list, and I'll get you the contact with the SNWG working group people. So I think this is all good for NASA to consider what would be NASA, for the next satellite that we need to consider. I think I just want to put a plug in there.
Okay. Thanks, Jennifer. There was a question in the back.
I'm just going to read one more on the line because I think it
Okay.
fits in the line of questioning. For the whole panel, this is from Jason Schroeder. What are the biggest observational needs for improving local scale forecasts for dust? So while we're going through our wish list.
I think one thing in Salt Lake is we're experiencing dust from a lot of flies, and they're very large. And so I don't have an exact answer, but more thought on how to deal with that large spatial area when we're experiencing dust from a lot of varied sources.
I think it's just always the answer is data, right? For us, for example, around the Salton Sea, we have those tools developed to simulate emission, but at the same time, we are also working on kind of real time kind of and so I think we would to speed validate those models. That would be good. So just emerging remote sensing technologies, I think those are great.
Yeah, I think definitely we need some good tools to do those, especially like right now when working on the PM10 in Rito, Arizona, is a small town. I think it would be great to have some like a source portion, like a tools can tell me if the dust storm happens, what the percentage is from the field, those deserts, but which from the facility piles or nearby sources. So we can definitely, we can do that, but right now it's take a lot of energy and also is time consuming. So if we have some tools or models can quickly get answer to the agency and to the public, that would be great.
Yeah, all good points. I don't have much to add. I think if one thing I would like to do, I think it might be useful, is to bring all the forecasts together from the data providers' perspective and come up with the probability forecasting, because dust is so difficult to predict, especially smaller ones. So sometimes we have to dance with that and to see what level of confidence you can get from those products, and how can you use that to inform your decision making.
Okay, thanks, Daniel. So before we go to the audience, I have one more question, which is from all of you. I mean, some of you are doing emission estimates, some of you are using remote sensing data, and you're doing forecasting. One of the fundamental question is, how do you validate all of this? What data source you need for validation? And are there challenges where the community can help? So.
Yeah, I can start with that. So I think we like to have all the data to validate the whole life cycle of dust storms, including emissions. So I think if we have some instrument like sensors or something on the real near source scale, that will be very helpful. And on the transport dust, we would like to have surface concentration, obviously. That's a very must have choice. And then also satellite to look at the entire column. And probably getting more important right now, we want to know the deposition. So some deposition, dry and wet deposition data will be useful as well.
Yeah, definitely. for me, I feel like I need a more surface ground data to validate the model results.
Yeah, I'd agree. I think bringing all these things together and using, at least for this stuff, I'm doing more ground-based measurements, which a little bit is that weather station we installed, but more things like that to sort of deal with some of the heterogeneity out on the Great Salt Lake and deal with the issues we have with such high levels of heterogeneity, so we can sort of validate with more continuously monitored sites.
So for me, our emission estimate methodology, it uses different tools, right? It uses remote sensing to map the surface. It uses pulse rule to develop a rule set relating friction velocity with wind speed, right? We also use wind modeling, and at the end, right, there's a dispersion modeling component. So there's uncertainty at every stage, right? Like, for example, on the emission estimate, like in the pulse rule, there is uncertainty. Characterizing the surface, right, the crust type, soil moisture, there's uncertainty. When you define the roughness, right, kind of length, there's uncertainty. So using different tools to kind of reduce those uncertainties at every step of the emission estimate process is critical. At the end, right, having those observations, like for example, TOM measurements at multiple locations, that would be good to validate the result. And again, those measurements will be just point measurements, right? You can have one TOM there and another TOM there, right? You could get different results. So having those remote sensing products to kind of validate it spatially would be good. So that type of validation at different level of the methodology would be critical.
My question's for Daniel. You mentioned the environmental justice implications of the dust. So we would expect inequitable impacts due to access to healthcare and other human behaviors, but do you actually have a sense for what would drive actual exposure to be inequitable? And what sources in particular might drive that?
Yeah, this is a wonderful question. I have not done any work myself on this, but my hunch is because people with no income will live closer to the source, and they probably are disproportionately impacted by the higher level of exposure to dust particles, as well as the microbes carried by dust storms. So and also people doing the field work like farmers, construction workers, they are probably are more heavily impacted by dust storms. So I will not be surprised if we see a large disparity in dust exposure and health impact on that.
Thank you.
Okay, can we get here microphone? She's getting it. Thank you.
I just had a question for all of you because a lot of us are aware from the air quality perspective, the impacts of dust on health, but a lot of the causes of the dust in the drying lakes are outside of, say, an air pollution agency to control, because a lot of it's based on water use, water diversion, all of that, drought. So I was wondering if you have any success stories of how the air agencies can work with other governmental organizations to actually, like the water boards or the legislature, to improve outcomes, and how that might be done in Utah.
Obviously, that's a good question.
I do not work for any agency, so I cannot really answer the question. Yeah, but I think it's very important to do cost-benefit analysis to understand what options you have. For example, is it better to control the source right now? Yeah, so you can avoid a negative impact, or you just divert the water use for other purpose. You get economic gain from that, but however, you have to carry the cost. I think this is a big debate for large sources like Salton Sea and also Owens Lake in California, and now the Great Salt Lake here. I think I saw Perry here. Steve, is Steve Perry here in the audience? he will be a wonderful person to answer this question. But in general, I think that's the strategy. We should do cost-benefit analysis and figure out what's the best option for the whole society.
For me, the second pillar is the proactive dust control, right? In that, like once high emissive areas are identified, the next thing is just researching, right, what can be done on that area, right? Just understanding, for example, the surface condition, right? The soil type, water availability, is there any water, right? Can we use kind of, more water efficient type of kind of vegetation establishment on those areas? So like, for example, for Salton Sea, there are multiple stakeholders working together. For example, kind of looking at groundwater development in the region to, to implement, water-based dust control measures. So that's, for example, like the California state is working with IID and California state. Those are, together working in, identifying those water sources. So as, kind of as an input to dust control measures.
To add from Utah experience, just there's been a lot of good conferences where they really try to get all the different stakeholders, researchers, both folks working in dust and air quality, as well as water conservation and politicians as well. And I think more work like that, getting all those different folks in the room, is probably one of the best ways to move forward on that. From a mitigation standpoint, it's pretty hard to do that on the Great Salt Lake, just because it's such a massive area compared to these other playas that we're talking about. So really trying to get water there is, I think, really important.
Okay, so there's a question on the back over there.
Hello? Yeah, it's sorry, that's too loud. It's probably more a comment on the on your previous question. I finished my PhD in 2020, and one of my mentors was Dr. Scott Bell, Dr. Van Belt, and the second chapter of my dissertation was about the finding association between anthropogenic effects, drought, and dust, and the like the soil on dust emission. And I found out in my dissertation, and I think we published that in Science of the Total Environment back in 2021, that we found that between agricultural areas, that was in the Southern High Plains, between the agricultural areas and the natural, let's say, deserts, like Chihuahuan Desert and stuff like that, that was our main domain, like compare between the Chihuahuan Desert and the Southern High Plains. And we found that with drought, if there's more drought, like as the drought intensity increases, the anthropogenic effects becoming more like have more contribution on dust emission. And the lower the drought intensity, probably that's will more likely will cause no association or between the anthropogenic factors and dust emission. Of course, this is just a preliminary study, and the small domain may be different, but just wanted to add this perspective. And thank you so much for Dr. Tong and the panelists. And I have a question, if I may. Now, satellites, the resolution of satellites is becoming more and more important in dust emission, and thus the temporal resolution, spatial resolution, all these stuff. And now we see more commercialized aspect to this, like PlanetScope and all that stuff. Excuse me if you mentioned this in the beginning, I wasn't here, but how NASA is going to work with commercial platforms to provide these data to end users who cannot afford to buy it? Thank you so much.
It sounds like a question for John. John, you want to chime in?
Yeah, I kind of flew by that this morning really quickly. As part of the expansion of applied sciences into Earth Action, we are bringing into the fold of Earth Action, our commercial satellite data program at NASA. It's not a new program, but it's going to be expanded as well. But it's been going on for many years now, where NASA, working with our private commercial partners, buys high resolution data for different portions of the globe. And that data is available to researchers and stakeholders to use in their projects. So we've already bought it and it's there for use. There are some conditions on how it can be used and all that through our agreements with the commercial data partners. But it's a great resource. In fact, once again, flew by really quickly this morning. For example, our preliminary work with Gates and Rockefeller is that they are accessing and looking at some of that high resolution commercial data for their own needs in sub-Saharan Africa. So as part of Earth Action, that commercial satellite data program is being elevated. We are in the process right now of hiring a permanent program manager for that program at NASA headquarters. And so we plan to continue to expand it over the next several years.
Thanks, John. We have a question here.
Michael Geiger, can I get Department of Energy and Environmental Protection? Daniel especially want to answer this question, I imagine, but Connecticut doesn't really have any dust issues, but some of you may have been aware of February, there was the Oklahoma dust storm, and we did a thorough analysis because we had a lot of press inquiries about this because people woke up a few days later and there was sticky muck all over their cars after a rainstorm. And we did track that dust actually making up to Connecticut, but people said it smelled. So we were wondering whether it was VOCs mixed in with them. They said it was kind of sticky. We didn't have this analyzed, but it's pretty curious what happened. And I tracked it with the back trajectories and went over the Permian Basin. Is that what it is over there in Arizona? Yes. Or which one? Yeah, West Texas. Yes, Permian Basin areas, and I tracked it right going over the flares. I did, because you get the Veers nighttime, the flares. Yes, the wind went right over the flares. I think, wouldn't that be interesting to know if there could be any interaction with surface emissions, with the transport of dust? So. The other point of this is that public messaging, because obviously people wanted to know, we couldn't conclude anything, but like the Illinois dust storm, was that forecast all? Is that the purview of the Weather Service? That they said, is there a probability of dust or air quality forecasters? I mean, was there this, if this was foreseen, what would the messaging be? There is a 50% chance of dust, for instance, something to think about for the future. I'm sure the people that were in the accidents, again, in Oklahoma and Illinois, would have liked to avoid them.
Yeah, I can start first. First on the dust storm that reached your region, I think you're going to see this more often, right? Because the Chihuahua Desert, northern Chihuahua Desert is drying up, because the river Rio Grande is drying up. So it will become a more active source region. And we are going to see large storms that cross the country. So that's bad news. The odor or the smell, I don't know. But in general, dust is a reaction platform. So there are a heterogeneous chemical reaction on the surface. And also once it's mixed with rain, you can have aqueous chemistry and generate a lot of chemicals that may give you the odor or the smell. Regarding Illinois and how to manage that dust risk, I think it's very difficult right now. First, the model is not up to the task right now. We do not know the ground conditions, right? If the farm has been tilled and we do not have the information, so we will need to have that information first. Second is a real accident, right? It's a very real in Illinois. And once you know the information, if I give you the information, give you to Michael, what do? You have to make the decision. Should I shut down highway? Was the highway 85 or something? Yeah. So you basically you have to shut down the highway for a couple of hours. That has a huge impact on traffic and commerce. you know, and the model could be wrong too. So it's not a light decision to make. I think, but it's a very good question. I think it's something that we have to work together to figure it out. Anybody else?
Okay, is there any more question? Okay, so this is going to be our last question.
I'm Merrill from, I'm kind of, listening to all of this and thinking about states, locals, tribes, and dust in the same way we think about wildfire smoke. Are we at a point where something similar to, for instance, the fire AQ briefings that were occurring out of University of Iowa at the beginning of every week that were perhaps helpful to state, local, tribal air agencies in thinking about where impacts might be? Is that something on the horizon? Perhaps we'll have a dust AQ at some point.
Great question. So Daniel, that's for you.
Yeah, I think that's a wonderful idea. We like to pursue that, but the question is, when and how we get it done. So I believe this is a huge impact on local communities, but we are not in that stage yet. The model is not ready, and I think there's a disconnection right now between the data providers and then the stakeholders. So Mary, if you want to help out, we welcome your contribution. Yeah.
Okay, I think we are on time now. So thank you all the speakers for wonderful talks and great discussion. So